Dear students, in today's class, we are going to see how to select a particular attribute by using entropy and information gain. As I told you in last class, to select a particular attribute for splitting your data set, you should be familiar with the terms entropy and information gain, which is whole and soul based on purity of your data, randomness of your data, certainty of your data. Okay. So, the term for selecting a particular feature of your data set for splitting is known as the attribute selection measure. And which are the attribute selection measures? Entropy, information gain, and one more is their gain index. So, based on different algorithms that you use for decision tree, each algorithm will use different attribute selection measure. Now, all of you know what are the terminologies that we are using in decision tree. Root node, the basic node from which splitting starts. Now, which attribute you will place as a root node, that will be decided by your information gain or gain index. Then leaf node is the node which is giving you the final prediction. Then splitting is starting from your root node so that you will get the subtrace. Okay, the subnodes or subset of your data is possible because of splitting only. Then branch means what? It is a part of the tree, the subtree. And pruning means what? The process using which you are trying to shrink your decision tree because your decision tree has grown very large. There are some unwanted paths, the paths that will be never followed in the prediction. Then such branches I want to remove. So that process is known as a pruning. And parent and child node means what? All the internal nodes are known as a parent node, and the nodes that are available in the next level of these nodes are known as a child nodes. Okay, so these are the terminologies. Now, what do you mean by attribute selection measure? The measure, the technique that is helping me to select the proper attribute, the best attribute, which is dividing my data set in a proper way. Okay, so one is a information gain and another one is a gain index. As I told you, ID3 algorithm will use the maximum information gain as a selection measure, while the CART algorithm will use the gain index. Now, there is a separate formula for each of these measures. Now, information gain is whole and soul based on entropy. Okay. Now, entropy means what? Impurity of your data, randomness in your data set, uncertainty in your data set. As entropy is high, it is having low purity. That's why entropy should be low. And when the entropy is low, then only the information gain is high. Now, what is the formula for information gain? You have to calculate the entropy of whole subset minus the weighted average multiplied by the entropy of each feature. Just remember the formula. With example, you will understand the formula in more detail. Okay, now the entropy. Entropy is measuring the impurity in a particular attribute. Okay, now it is specifying the randomness in data. Now, in binary classification, you will have two classes. One is a yes, the another one is a no, means positive class and negative class. Now, what you are doing is you have to find out the probability of positive class and multiply it with the log of itself minus the probability of negative class and multiply it with the log of itself. And you have to take the addition of these two, that is the summation, and then minus it. Okay. Now, Gini index will do what? 1 minus the sum of all these probabilities squares. Okay. That is what the Gini index. I told you, Gini index is used as a ASM, that is an attribute selection measure for which algorithm? CART algorithm. CART means what? Classification and regression tree. What do you mean by CART? The classification and regression tree. Okay. Now, how we are calculating the Gini index? 1 minus summation of probability of each feature and make it square. Okay. Most probably, we will see the example of information gain only for your ID3 algorithm. Now, let us see how we can calculate the entropy and information gain. Now, this is a sample data set in which I'm considering only one feature, that is the color, and I'm having only two classes. One is a positive, another one is a negative. So how many positive values I am having? 6 yes are there. And how many no are there? 4 no's are there. Okay. So out of 10, 6 are yes, 4 are no. So how will be the probability? 6 by 10, 4 by 10. Okay. So the same I will apply here. The probability of yes will be 6 by 10. The probability of no will be 4 by 10. Okay. So 6 by 10, multiply it with the log of 6 by 10 to the base 2 plus 4 by 10, multiply it with the log of 4 by 2 to the base 10. So what I will get? 0.971. Now suppose all the 10 values are yes. Then in that case, I will get 10 by 10 multiplied by log of 10 by 10. Means 1 multiplied by log of 1. 0. When I am having all yes, very zero randomness. Okay. Means what? It is most pure. And when you are having most purity, means what? Less entropy. Okay. And now when I am having equal number of the classes, then in that case, my entropy is what? 1. Means it is indicating the high impurity. Okay. Now, what I will do is the obtained entropy is whose? The whole data sets. Okay, yes means what? Whole sample space. Now I want to find out the entropy of each feature to find out the weighted average. Okay, so you can observe that in our data set, how many red values are there? 6. How many yellow values are there? 4. Okay, so out of 6 red values, how many yes are there? 1, 2, and 3. Okay, and how many no are there? 3 no's. And out of 4 yellow values, how many yes are there? 1, 2, and 3. Yes, and 1 no. So remember these values. Now, as I told you, there are 3 yes for red and 3 no's for red. So it will come as 3 by 6. Okay. And out of 4 yellows, 3 are yes and 1 is no. So by doing the calculation, I will get the entropy of your red as 1 and entropy of yellow as 0.811. Now, when I take its weighted average, out of 10, how many red are there? 6. So multiply it with its entropy 1. And out of 10, how many yellows are there? 4. So multiply with its entropy. And finally, I will get the weighted average. So this weighted average should be subtracted from the entropy of your whole subset. That is the 0.971. I'm subtracting 0.924. Then I will get this as my information gain. So as this data set is containing only one feature, that will act as a root. But in your assignment question, you will have a data set in which many features are there. So you should calculate the information gain for every feature. And the feature that is having the maximum information gain should be treated as a root. And in the next level also, you should repeat the same process. So this is what the role of entropy and information gain for selecting the best attribute as a root and repeating same process in the next level as your tree is progressing. Okay. Thank you.